Okay, we're ready for Notes 8B with the Math 4 course, and we'll start with a little cow pie bingo. Um, you'll notice on the ground that there are white stripes, and what someone has done is marked off 5-foot squares, 5-foot length on each side, and there are, I don't know, there could be 1,000 of them in this field. And so, this story goes back to my days of radio back in when I was in Roanoke Rapids, up at the Virginia border, which of course is very much out in the country. And so there was, I don't know, the Shriners or somebody that was having this as a fundraiser, that they took a pasture and gridded it off into 1,000 5-by-5-foot squares, and they sold the raffle tickets for like $5 a piece, I think. And so you stop and think about it, that would draw in $5,000. And so what they would do is that each ticket would correspond to a particular square. You were, in a sense, you were buying your own piece of real estate. And the way that the game was won is that they would set a cow loose in there and wait for nature to take its course. And as soon as the cow left a deposit in one particular square, that person would be the winner. And so, you could have, $1,000 prize and still walk away with $4,000 profit for the group. So, this was a very popular fundraiser back in the 80s when I was working radio in the North Carolina, Virginia area. But anyway, this gets into the kind of games, and there's a certain element of natural chance involved with where is the cow going to do his business. But anyway, we are taking probability distribution and we are figuring out the expected value of that. Now, oops, I got to turn on my pen. The expected value is that if I were to play this game 1,000 times, what would be my average winnings? All right, what is the average gain or loss that would occur over a long series of trials? That's the expected value. And obviously, you want the expected value to be positive rather than negative. This is one of the ways of determining whether a game is worth getting into. Now, at the same time, if you have a game where your expected value is 0, that means you're expected over the long run not to win or not to lose, but to break even. This is what they call a fair game. And it really does come down to chance of, whether you win or lose. Now, our first example is we are going to play with a kiddie pool full of ducks. It's Homecoming Carnival, and they're doing this as a fundraiser. So they put rubber duckies in a kiddie pool. There are 50 ducks in all, 2 have stars, 6 have circles, 15 have squares. And the prize winners are vouchers for the concession stand at the football game. So you can see the way that the prizes are listed there. And then they'll select one ducky and the prize is awarded, and then the ducky is returned to the pool for the next game. Anyway, let's move on with this. Our probability, there are 2 stars out of the 50 ducks. There are 6 circles out of the 50 ducks. And there are 15 squares out of the 50 ducks. Now, when you think about it, 2 and 6 make 8, plus 15 is 23. That would mean that there are 27 left over that have no symbol whatsoever. Now, our prize money would be $5 for the star, 2 for the circle, 1 for the square, and nothing if you have no symbol. Now, the idea here is to multiply down and then add across. It is really that simple. All right, so I'm going to pause and do the multiplication here. All right, that is what you're multiplying down. 2 divide 50 times 5. 6 divide 50 times 2. This is what you're going to get. And then you're going to add across all of these results, and you're going to get that, which our prize money was in dollars, so this is going to be in dollars. Your expected value is 74 cents. Now that's if the game were free. They are in the business of trying to make money for the athletic program, so we're going to scroll down and see, all right, what happens if they set the cost at $1 per try? All right, well, you still have the same probabilities in all 4 cases, but the prize money here is $5 less the dollar that it costs to get in. Here it is the $2 less the dollar that it costs to get in. Now, if you spend $1 to get in and you win $1 back, you just broke even. And of course, if there's no symbol, you spend your $1 and you get nothing back. So you've just lost $1. Now, let me pause and do some calculating. Okay, so there is all of those put together. And then we add them. This guy is negative because we didn't win anything, but it cost us $1 to get in. So this is going to wind up with a negative 0.26. So yeah, technically speaking, we're losing a quarter every time we play this game. Now, losing a quarter is not that much, and it is to raise money for the athletic programs. So, most people would say, yeah, even though it's not in my favor, I'm still going to play the game because I might win something, and even if I lose, the money goes toward charity. So there are a lot of charity casino nights that happen that way. That they will, you make a donation to get in the door, and then they give you a stack of chips, and you just play like you were at Vegas or something like that. I'm not sure if there are prizes involved in that or not. There may be. Well, they have to be careful because if it costs you to get in, and there's an element of chance, and there's something of value to be won on the other side of this, they consider that a lottery. And the state has controls. You can't just have a lottery anytime you feel like it. Yes, we have the North Carolina Education Lottery. Yes, you can go up to Cherokee and play the casinos up there. But and yes, you can even go to some storefronts that have the computerized poker playing or something like that. But the state does have laws about this, so you have to be careful of that sort of thing and make sure that you're not breaking the law. But all being said, you're losing money in favor of the athletic program. I can think of worse ways to go. All right. Now, Norbert is considering 2 different kinds of fire insurance policy. And I don't know how much you know about things about like insurance or realtors, and we're going to have some education today. First of all, with fire insurance, company A charges $300 a year, and if you have a fire, they'll give you the full value of the home. That's assuming the fire takes the entire home. Company B charges an annual premium of $200 instead of $300. It's cheaper, but they'll only reimburse you 85% of the value of the home if it burns down. So it is cheaper, but you're getting less coverage. I've always said that with insurance, by and large, you get what you pay for. I have a student that has been trying to choose car insurance, and I've made that same point that if you go with the cheapest rate you can find, and you have an accident, you may find that they're not that easy to work with. There's something to be said for having a local agent that you can go to that person and say, I just totaled my car, how can you help me? and it's their job to help you. All right, now they're saying the probability of a house fire is 0.0004 in Overton. So our outcomes are either fire or no fire. And there is a 0.0004 chance of having a fire, which means that there is a 0.996 chance of not having a fire. Now, honestly, I've been alive for more than half a century. I have never been involved in a house fire. Never. Nobody that I know has been involved in a house fire, at least not close family. I live in a neighborhood with probably 150 houses. And in the 20 years we've lived here, I know of one house that burned to where it had to be replaced. That's once. So anyway, now we have to figure out for company A, if he gets the 180,000 back, but he had to spend 300 to do it, that's going to be 179,700. So if he has a fire, that's how much he gets back. But if he has no fire, he has just lost his premium of $300, and that's it. So now we're going to figure out, we're going to multiply those two and then add them together. All right, so I've done the multiplication there, and we wound up with these two figures that we're going to add together, which by the time that I subtract the 299.88, it comes out to be a negative 228 even. Now, before you jump on this and say, whoa, that's not desirable at all, understand that he could go through, I've paid annual premiums of probably $1,000 a month. Well, maybe not $1,000, maybe $500 a month for 20 years and never once claimed on it. That's a lot of money out the window, So anyway, this is not such a bad thing. You know that by and large, the only way that this becomes positive is if your house burns down, which you don't want that. Most folks do not. It's a pain in the rear to have to rebuild, not to mention losing all of your valuables inside the house. So now let's look at company B. So we're going to say, all right, it's the same kind of conditions. There's either fire or no fire. The percentages are the same. But here we have to figure out, if he pays $200 a year and he has a fire, he gets 85% of the value of the home. We have to stop and figure out what is 85% of 185,000. All right, small mistake there. It was not 185. It was supposed to be 180,000. And by the time I multiply it by 0.85, I get 153,000. Now, there is that $200 premium. That's going to be 152,800. And meanwhile, here we lose our $200 premium if there's no fire. All right, so by the time we do the multiplication down, we wind up with those two that we're going to add together, which turns out to be 138, negative 138.70. No, 72. Yeah, 138.72, yeah. So our expected value here is negative 138.72. Here it's negative 228. So just looking at the expected value, the second one looks like the better deal. And so, we could say company B has the better EV, better expected value. But, there is this question of, let's say that he loses his home and everything. And he had a $180,000 home, and they're giving him $150,000 for it. That's $30,000 loss right there. Can he afford? I guess that would be $27,000. That's a very real question. It depends on his situation, what kind of job he has, what kind of family responsibilities he has. Can he just simply take his $153,000 and go buy a smaller home? Is that doable, or does he still need to have the full size because he's got a big family? There are unknown variables involved in this as far as to which one he should choose. Now, as far as the better expected value, that's going to be company B because he's only spending $200 a month, and Lord knows if he'll ever need the fire insurance. But honestly, that's why it's there, because Murphy's Law rules. Anything that can go wrong will go wrong, usually at the worst possible time. And so, it's kind of like health insurance. You don't think you need it until you need it, and then suddenly you realize going to the hospital, if you have to pay all the bill, you're going to go broke. And so that's why people buy health insurance, is so they don't go broke, when they're hit with catastrophic loss, because it does happen. All right. Now, something that's a little more fun. Prunella is talking with mom and dad, and she wants money. And so mom and dad each have a plan to give her money based on random chance. So we're going to talk about mom first. Mom is picking from a standard deck of cards. If she picks a red card, she gets 15. If she picks a black card, she gets nothing. We have to back up and remember our knowledge of a deck of cards, that there are 4 suits in the deck. 2 of them are red, 2 of them are black. And every suit has 13 cards in it. So, the red cards would be the diamonds and the hearts. That's 26 out of the 52. That is literally 1/2. So, we're talking about the probability of drawing red versus drawing black. And you literally have a 50-50 chance either way. Now, if she draws red, she gets $15. If she draws black, she gets nothing. So half of 15 is 750. Half of 0 is still 0. So her expected value with mom is 750. All right, that's not bad. Let's see what's up with dad. Now, dad is going to roll a die. And of course, if you're rolling a die, you could have anywhere from 1 through 6. And there is a 1 out of 6 chance on each one of those, presuming that it is a fair die. And he is going to give her $3 for each dot. That actually sounds pretty good. If I have 1 dot, I get $3. If I have 2 dots, I get $6. 3 dots, I get 9, and so on and so forth. You can just work your way up. Now, we're going to multiply 1/6 times 3 is 3/6, which is 1/2. 1/6 times 6 is 1. 1/6 times 9 is actually 1.5. You can see the pattern growing here. And so we're going to go back and we're going to add those. And they add up to be 1050 for the expected value. And not only is that better than mom's expected value, but there's another thing about dad's offer too. Dad has better EV. But also with that, when you think about it, with mom's plan, there's a 50-50 chance that you walk away with nothing. But with dad's plan, you're going to walk away with something. It may just be $3, but you're going to walk away with something no matter how you roll the dice. That's not a bad plan, at least as far as Prunella is concerned. That means she'll always have something. All right. Now, Bertha is a realtor. Then we need to go into something here. When you are going to sell your house and you approach a realtor and they are going to list the home, that means that you have signed a contract with her that says that she has kind of control over how this thing is sold. Now, somebody else can come in and bring a couple. Well, here's the thing. Bertha has certain people that she's been talking to that she's trying to get them into a house. There are other realtors that have their own people that they're talking to, trying to get them into a house. And so if another realtor brings in their couple and they like the house and they make an offer on it and they sell it, that other realtor is going to get a piece of the pie. The commission is 6% of the sales price, usually split 3% for the person who lists it and 3% for the person who sells it. So that means Bertha could get just 3% for listing it if somebody else comes in and sells it. Or if she sells it herself, if she's the realtor that's working with a couple that makes the bid and they get the bid and they win the house, that means she gets both the 3% for listing and the 3% for selling it. So, there are three possible outcomes here. One is that Bertha sells it. There is the possible outcome that another realtor will come along and sell it. And then there is the possibility that it's not going to get sold within the 3 months of the contract. At the end of the 3 months, contract is over with, and Bertha has no more claim to any commission, not unless they sign another contract with her. Now, they're saying here in the last sentence that she figures she has a 30% chance of selling it herself, another 30% for somebody else, and then 40% that it doesn't sell at all. One thing that we need to figure out here is, first of all, what is 3% of 350,000? And the answer is 10,500. Now, if she sells it, she gets both the 10,500 for listing it and the 10,500 for selling it. But there's also a cost in here. Because she is listing it, she is taking on a $2,000 cost for advertising and open houses and stuff like that. It's going to cost her $2,000 to put this thing out in front of the general public. And so that's $2,000 that kind of has to be taken off at the tail end. That comes out to be $19,000. And so if she sells it, in addition to listing it, that's what she's going to make after her costs. Now, if somebody else sells it, she still gets the $10,000 for listing it, although she still spent $2,000 to advertise for it. So that's going to leave her with $8,500. That if somebody else sells it, Bertha will still get $8,500. And then if nobody sells it, then she is out the $2,000 that she spent on the advertising. So now we've got to multiply these down and then add them together and figure out what does our expected value look like. Okay, so by the time you add these two and subtract the 800 from the total, you get $74.50. So that is not a bad expected value. Yeah, there is a 40% chance that she could lose $2,000 in this, but there's also a reasonable chance she could make 19 grand off the deal. I have a brother-in-law that lives in the mountains of Asheville that is in the real estate business, only his thing is not houses. His thing is large tracts of wooded land, like tens of thousands of acres, up in the mountains. Nobody can get to them, but they have trees on them that are valuable for logging. And so he will sell tracts back and forth between landowners and logging mills and that sort of thing. And, he will, because the value of the thing is so large, and because almost nobody else is in that business, he takes the entire 6% most of the time. And all he has to do is sell one big tract of land, and their household budget is set for the rest of the year. Yeah, there is good money in being a realtor, but it comes with its dry spells sometimes too. All right. So should she take the listing? I would say yes. Presumably if she's making 19,000 and 8,000, then a $2,000 loss, it can be absorbed. We're going to run into a situation a little later on where we're going to ask the question, can this person afford this loss? All right, construction company wants to submit a bid. They need to spend $3,500 to make the bid. That's what it's going to cost them to put everything together to make the bid. If it's accepted, they'll make $22,000, but there's only a 20% chance of being accepted. All right, so we're going to say they either accept or reject their bid. There is a 20% chance of accepting it. There is an 80% chance of them rejecting it. That right there sounds ominous. But let's look at the numbers. All right, so if you could make 22,000 on it and you spent 3,500 to make it happen, that's going to be 18,500 that you would clear on that job. Now, if your bid is rejected, then you've lost the 3,500 you spent on the bid. So let's see what happens here. All right, so this one is going to be 3,700, and this one is going to be negative 2,800. So we'll still come out $900 to the good. So our numbers tell us this could be a good deal. Now, this is where, would you advise the company? I'm going to say yes, unless losing 3,500 is the problem. Because you're going to have some companies that live a little too close to zero, and they're barely making ends meet. And so to lose $3,500 on something that you have an 80% chance of being rejected, you do have to spend money to make money, but the question is, can you lose 3,500 like that? Now if you're talking about making 18,000 on a job like this, you could lose 5 bids like this and still come out ahead with 18,500. So there is, sometimes it is a numbers game. You have to put enough bids out there and you'll lose money on most of them. But the ones that get accepted, hopefully you'll make money. All right, last one here. Yeah, this is the last one for the notes. Is something that used to be a lot more common in airports. I don't see it so much anymore. That is, you have like an ATM kind of machine, but it actually would sell you a life insurance policy for your flight. You know, if your plane goes crashing down, then your loved ones get $100,000. You know, and for some people, it's worth $5 to have that kind of coverage. Now, you know, well, past records indicate one death per million passengers. You know, that's a very small percentage. So let's see what the numbers say now. How much can the company expect to gain on one policy? We are doing this from the company's perspective. Now, there are two outcomes. You either live or you die. Now, if you live, well, let's do the one death per million passengers. Your probability of dying is going to be tens, hundreds, thousands, 10,000s, 100,000s, million. One with 5 zeros in front and then the decimal, which means that your chances of living is going to be 6 nines. All right, so if you live, the company expects to gain $5. But if you die, you're going to lose 100. You know, the company is going to lose 100,000 less the 5 that they got from you before your plane crashed. So now we multiply. All right, I forgot that with the 99,000, the company is going to lose that money, you know, because they're going to have to pay it out as a claim if somebody dies. So when we add these two together, we wind up with $4.90 as expected value. Now, considering that it cost $5 to get into this, $4.90 is not bad. As a matter of fact, if you did this 100,000 times, would be $490,000. You got to understand about insurance like this, that they're in this to make money. They're not going to take on a risk unless the numbers say that they are more likely to make money than lose money. And so this sort of expected value is huge in the insurance industry. And you know, usually it has to do with life insurance, mortality rates. What are the things that contribute to somebody dying earlier rather than later? You know, this is all part of the game, as it were. All right, well, that is the end of the notes.